residues in drinking water, capacity building for water management in Central Europe. For the Today conference, we have prepared an overview of activities and results of the project prepared by our project team, and we would also like to discuss our results with you, our honored guests. And for the beginning, I would like to ask Mr. Josip Terzic, a representative of lead partner, which is Croatian Geological Survey, to give us opening words and a short introduction to the project realization.
Yes, good morning, everybody. Can you hear me? Everything okay?
Yes.
I hope. I see I can share my presentation now. Do you see the presentation?
Yes, we see it.
Yeah, thank you. Okay, so we'd already read the project title. You can see it now. It's Board for Detection and Assessment of Pharmaceutical Drug Residues in Drinking Water, Capacity Building for Water Management in Central Europe. I am a representative of Croatian Geological Survey, a lead partner of this project. This presentation is just an introduction, and you will see much more in following presentation, thematic presentations afterwards. So in this presentation, I will briefly present facts and figures, present our partnership, our objectives, structure and timeline, outputs and the results, indicators, of course. So these are basic facts of our project. It started in the April 2019 and will be finished very, very soon, until the end of March this year. We included partners from 7 countries, 12 partners and 7 associated partners. The total budget of the project was over 2,300,000 euro, and ERDF co-financing was almost 2 million euro. You can see the figures here. We have this project in the program priority, cooperating on natural and cultural resources for sustainable growth in Central Europe, and the specific objective to improve integrated environmental management capacities for the protection and sustainable use of natural heritage and resources. This is a map of our program area in Central Europe. You can see that we covered this Central Europe region quite well. We have 12 project partners. 2 are from Croatia, Germany, Italy, Poland and Slovenia, and 1 from Austria and the Czech Republic. We also have 7 associated partners, 2 from Germany and 1 from Austria, Croatia, Czech Republic, France and Poland. So this is our partnership. You can see it's Croatian Geological Survey and Split Water and Sewerage Company from Croatia. Yeah. From Czech Republic, there is the University of Life Sciences in Prague. From Slovenia, we have Vodovod Kanalizacija Ljubljana and University of Ljubljana. From Poland, we have University of Silesia and Silesian Waterworks. From Germany, Technical University. And the Center for Applied Research and Technology at Dresden University of Applied Sciences. From Italy, we have Regional Agency for Prevention, Environment and Energy in Emilia-Romagna and the District Basin Authorities of Po River. From Austria, there is University of Natural Resources and Life Sciences from Vienna. Our associated partners are Croatian Waters in Croatia, Karani Waterworks from Czech Republic, Polish Waters from Poland. From France, we have associated partner. It's a partner of German partner, Technical University of Munich. It's a Norman network of reference laboratories, research centers, and related organizations for monitoring of emerging environmental substances. Also, German partners, we have Saxon State Office for Environment, Agriculture, and Geology Department for Urban Water Management and Groundwater, and Drevagnets. It's a company division of facility management, drinking water, and central heating. From Austria, our associated partner is Municipality of Weidhofen an Ilz, division Waterworks. The objectives of the project can be summarized as based on the innovative approach applied in identification pilot areas across our countries, the lack of knowledge on emerging contaminants, or ECs, specifically origin, behavior, transport, and fate of pharmaceuticals and personal care products, PPCPs, as we call them, will be tackled by means of developing and testing of appropriate monitoring and modeling activities in different hydrological systems under environmental pressures. The design of an integrated management of waterworks that guarantees increased quality of drinking water, and specifically study of PPCP in the natural environment, technological aspects of PPCP attenuation, and waterwork decision support systems. You will hear a lot about all these objectives in following presentations. This is the structure of our project, our Gantt, how we did the job. Of course, with thematical work packages. It started with discovering of EC in the water environment, state of the art, what was done, what was discovered until now. And also from the beginning of the project, we started with our monitoring of PPCP in the water environment, our pilot areas. There is separate presentation about them, of course. After that, we also started with modeling of emerging contaminants, model application. And of course, in the end of the project, it was a study of attenuating of emerging contaminants, prospects, and new approaches. Our very important partners were, of course, leaders of the thematic work packages. One was from Slovenia, University of Ljubljana, state of the art. From our Czech partners, university, we had joint monitoring methodology implemented in 8 designed pilot areas grouped in 3 clusters: surface water, groundwater, and karst water resources. Technical University from Munich has led the thematic work package hydrological models and PPCP transport models in 8 pilot areas. And our Croatian partner, Big Split, a water supply company, was leader of the last thematic work package, attenuation strategies, catalog of technical and management solutions for PPCP mitigation, capacity building for waterworks, and of course, board of experts. Our outputs can be grouped like this. So you can see this is a strategy, transnational strategy for PPCP mitigation in drinking water, Trust PPCP as we call it. Then some tools, state-of-the-art of current practices in relation to emerging contaminants in the water environment, data collection tool for emerging contaminants, a model-based decision-making tool for EC, ModProcon, decision-making support tool for waterworks, they must. Also, we have done a training, a standardized training procedure for ModProcon implemented in a massive open online course. Here are our pilot areas, as you can see, but as I said, there will be a separate presentation. I will not read them again. Pilot actions are, of course, some of the major outputs. Also, implementation of ModProcon showcasing for groundwater pilot actions, implementation of ModProcon showcasing for surface water pilot actions, and for karst water pilot actions. We have reached several indicators. Here are some of the most important. We have established a board of experts, established as a non-profit association of interested experts who focus their efforts on the burning issue of emerging contaminants in water resources and have agreed to collaborate beyond project's lifetime. There were some letters of interest, institutions interested in testing the applicability of the developed decision-making support tools such as ModProCon. We had several online training courses and educational videos, the tutorials for application of decision-making support tools, ModProCon, project promotional movie, and movies covering monitoring activities in Croatia, Poland, and Austria. We have reached lots of stakeholders, as you can see in these numbers. Mostly these are general public as an end user of water-related services, and PPCP users reached during project conferences, discussion panels, and public events organized by partners at national levels. Also, national, regional, and local public authorities reached during project events, dissemination of results, and different communication channels. Of course, maybe the most important, water suppliers as main target group and potential user of ModProCon, wastewater treatment responsible companies. And in the end, of course, scientific part, universities and research institutions in the field of water management, water environment, health, etc. In the end of the presentation, I would like to present our team of the lead partner, Croatian Geological Survey, our Department of Hydrogeology and Engineering Geology. I was leading the team, and here are also my colleagues, Dr. Jasmina Lukač-Šeberski, Ivana Boljak, Ana Selak, Matko Patekar, and Marina Filipović. Especially, I have to emphasize that Jasmina, Ivana, and Ana have done most of the job, and I would like to thank them for that now in the end of the project. And thank you for attention. These are just logos of our institutions.
Thank you, Josip, for interesting presentation and overview of the project. Before we start with presentations, I would like to mention that we will have some time for questions and answers after each presentation, but we can afford a general, wider discussion at the end of the conference. And because we know that it's good to note your thoughts already during the conference, we encourage you to write your notes, suggestions, or simply thoughts about the topic, things that you would like to discuss. And you can do that by using Mentimeter. It will be, you can access it through a link which will be provided to the chat section by our colleague Joanna Čekaj. And actually, there will be 3 links. One will be through the first one, you will be able to note your questions, and there will be 2 more. And we would like to ask you to give us also information about where are you connected from and what kind of the institution do you represent. So feel free to use these links during the conference, and we will get back to Mentimeter for our discussion session. And now we will start with the first session of the conference. And before we get to project activities, we will listen to a presentation of legal aspects on PPCP problem in drinking water, which will be given to us by Ms. Klara Ramm. Klara Ramm is a mechanical engineer with a PhD in water supply and an MBA. She gained experience in both public and private institutions. She is an expert in risk assessments, in water supply, feasibility studies, market analysis, etc. She cooperates with the Polish Waterworks Chamber of Commerce, implements national and international projects related to water management, and since 2006 she has been active in EurEau, European Federation of Water and Wastewater Services. She represents Poland in the General Assembly and in the Committee on Economic and Legal Affairs. She chairs the group on the value of water service, and she was a member of the first board of mission Restore Our Ocean and Waters for the program Horizon Europe. So we are honored to have here this guest, and please, Ms. Klara Ramm, the floor, or I should rather say the screen is yours.
Thank you. I hope that you can just hear me. I will so share the presentation. Just a second.
Of course,
okay,
we hear you very good.
Okay, and you can, if you can hear me and if you can see my screen, it's already perfect.
Yes.
So let's start. I would like firstly thank the organizer for the invitation to this meeting. Very interesting topics you mentioned. I represent the Chamber of Economy Polish Waterworks and EurEau, so the Federation of Water and Wastewater Services in Europe, and I will just share with you some ideas, our ideas about water and wastewater services and our problems with micropollutants, especially pharmaceuticals. So we have started by principal rules. So the precautionary principle, which is very important in the area of just mitigating and fighting with micropollution. So the precautionary principle detailed in the Treaty of the Functioning of the European Union, it aims at ensuring a higher level of environmental protection through preventive decision taking in case of risk. So it has to ensure an appropriate level of environmental and health cooperation between all member states. And we have also control at source and polluter pays principle, also very important principles in the EU law. So the water sector recognizes the role of wastewater treatment plants as an important barrier, but at the same time a main pathway of many pollutants to the environment. So that's why we do insist on control at source measures along their whole life cycle as the most sustainable solution. Certainly particular attention should be paid in this context to pharmaceuticals. Obviously, you very know all this definition of pharmaceuticals or micropollutants and pharmaceuticals, as well as emerging substances. Although we have a generally good understanding of the main products group responsible for the presence of micropollutants in waters, their effects on complex aquatic ecosystem is currently poorly understood. They usually occur in low concentrations, in changing mixtures, and are a part of multiple other stressors. So here is the problem with them. And as you can see on this slide, EU legislation contains many elements related to the precautionary principle. As you can see of the diagram, the cross-cutting solutions cover many products. However, it is
I would just like to say that we still see your first slide.
Sorry, I don't know why. Really, I don't know.
So try maybe to set full screen once again, to turn it off and on.
Full screen.
Or if you're using two monitors, maybe it would be better to turn off one of them to leave just the main.
Yes, 1 second. Okay, and now it's this second. Okay, and it's okay now, or I use only one, so
we still see the first slide.
So I really don't know why, because I can see. Just a moment, maybe I will share not. I will share on my screen, maybe not only.
Yes. You should stop sharing and then start sharing again whole screen, not just PowerPoint.
Okay, I'm very sorry for this, but. And now I share all my screen. And now
yes, I think this is now okay.
This is the screen about micropollutants. Yes, so you named the issue. So we will go further with all these.
Thank you.
Okay, so you can see this slide on all this EU legislation that contains many elements related to the precautionary principle and the cross-cutting solutions covering a lot of products, including pharmaceuticals. So the problem is that at EU level, a harmonized and comprehensive list of the production numbers, use, emissions, toxicological properties and environmental effects of micropollutants is lacking. In 2021, the European Commission published and launched a consultation on pharmaceuticals strategy. EurEau took part in this consultation. We are waiting for the feedback, and you can see that the goals that European Commission proposes are right and very positive. So we will see what would happen next. But EurEau highlights, as water sectors, we highlight the importance to introduce environmental quality standards. However, they must not automatically translate into end-of-pipe measures at the level of wastewater treatment plants. So in line with the EU treaties, a holistic approach must be applied, starting from the precautionary principle, preventive and control at source principles. We have also new drinking water directive, which is very important because thanks to the Article 9 and Article 7 and risk-based approach, we have this opportunity in this context to assess also environmental quality standards for pharmaceuticals, and it will provide a crucial support for the protection of drinking water resources. But we also believe it's important that necessary preconditions are followed up as framing the consequences of setting European quality standards. So first of all, European quality standards should be based on sound scientific data and the precautionary principle. Enough high-quality environmental data for candidate pollutants should be available for different trophic levels, also in water. Once an EQS is established for pharmaceutical substance, it will be subject to monitoring in the environment to obtain representative information of the water body. EQS must always lead as a priority to control at source measures to avoid unsustainable and end-of-pipe treatment. The environmental risk assessment carried out for pharmaceuticals should be a compulsory element of the risk-benefit analysis within the authorization process. If a pharmaceutical is harmful to the water environment, it should only be sold under medical prescription. So their over-the-counter OTC sale must be banned. And moreover, we can use the same mechanism foreseen under the pesticide regulation. So if the EQS for a pharmaceutical is exceeded, its authorization should be reviewed and mitigation measures should be taken. And moreover, if a medicine is already sold under prescription, authorities should publish recommendations for less environmentally hazardous alternatives. The effectiveness of stricter requirements for wastewater treatment plants must be obviously evaluated against the protection of water resources according to the Water Framework Directive. And information on pharmaceuticals gathered not only in the context of risk assessment, but also in the, for example, post-authorization phase, should be transparent and accessible for water operators just to adapt to the situation. And the last conditions are that end-of-pipe treatment, if it is required, the polluter pays principle should be applied, so including through extended producer responsibility schemes to recover the cost of additional water treatment to remove pharmaceuticals. So these polluter pays principle and extended producer responsibilities are very important, and it could be complicated because the combined impact of cocktails of several chemicals and their transformation products should be also considered. So a few years ago, EurEau carried out a feasibility study on applying extended producer responsibility to micropollutants and pharmaceuticals as well, just to assess environmental, health, and economic impact. We defined the main entry pathways of pharmaceuticals into environment, and in this graph you can see main and minor pathways. So domestic household are very important pathway because of incorrect disposal of the expired medicines and their leftovers. Also hospitals, when they don't have appropriate wastewater treatment, and also unused and expired medical products which are disposed in landfilling, and because of leachate, they are also harmful for water bodies. As well, veterinary use of pharmaceuticals for animal farming, especially large intensive animal farms and aquaculture, and at the end industrial chemicals, but they are rather minor pathways thanks to the industrial wastewater treatment plants. So the main issue, the main tool must be control at source. It's the main tool. And you can see the definition that it consists of actions taken as far as possible by implementing measures to reduce or even phase out substances and products that emit micropollutants, pharmaceuticals as well. The most sustainable and preferred solution is therefore to prevent pollutants from entering the water cycle. Control as source approach involves the implementation of two types of actions, including legislative and also voluntary actions. And NO5 is the last resort solutions, but sometimes necessary. However, the use and operation of advanced treatment technology entail high cost and can result of high energy demand. And for example, according to Swedish Environmental Protection Agency, it will result in case of ozonization and ultrafiltration techniques, even the energy consumption rise for operating these technologies is estimated even 0.55 kilowatt hours per cubic meters. And for example, in Switzerland, additional treatment processes will result in increased energy consumption, even till 30%. So we have to pay attention to these end-of-pipe solutions. In addition, it needs sometimes increased training skills, so additional competences. Moreover, some advanced water treatment processes can generate byproducts of unknown chemical structures and fate and toxicity. For example, several studies have shown that wastewater treatment by ozone may result in selection of antibiotic resistance genes in effluent. Also, higher space requirements sometimes are needed. Sometimes the combined sewers overflows are problematic, and the efficiency rate of different advanced water treatment technologies vary greatly depending on the technology. So, for example, SEPA study found that none on the advanced treatment technologies studied applied individually can achieve a complete removal. So some combinations on different technologies will be needed, and just to ensure the complete removal of pharmaceuticals. So that's why we insist on extended producer responsibility, which presents significant opportunities to address the serious challenges of micropollutants emitted into the aquatic environment. This policy is some kind of policy approach under which producers are given a significant responsibility, financial or physical, for the treatment or disposal of post-consumer products. And EPR is therefore an approach that recognizes the producer's responsibility for the products they place on the market, which extends beyond the production and consumption stage to its end of life stage. An important aspect of EPR is to provide incentive for producers to take into account environmental consideration along the product life cycle by improving product design, using alternative substances, etc., etc. So this application of EPR at EU level would be more effective compared to the national level in terms of being able to fully address the scale of micropollution problems. So it is briefly what do we think about how to fight with micropollutants using already existing EU tools. Thank you for your attention.
Thank you for a nice presentation. I think this was a very nice context also for our project. We have time for some short questions and answers. And if you have a question, you can raise your hand, which you can find in meeting control bar. And then we will confirm your request, and you will be able to turn on your microphone. So if somebody has a question, please go ahead, find your virtual hand and raise it. As I already mentioned, there will be also time for discussion already also after, at the end of the conference. We have a question. So Mr. Krzysztof Filipek, you can turn on your microphone. So, Mr. Filipek, if you have a question, please try to turn on the microphone. I think it should be enabled now.
Okay, now?
Yes, we hear you. Great.
Okay, I'm sorry. So I'm Krzysztof Filipek. I'm calling from Poland, Górnośląskie Przedsiębiorstwo Wodociągów, Silesian Waterworks. Klara, I have a question. You mentioned the idea of end of pipe, but in my opinion, in this case of PPCP, the end of pipe understanding as, for example, wastewater treatment plant is the most convenient place, because in this place, the PPCP are highly concentrated and therefore they are relatively easy to treat, to remove. Of course, this prevention idea is also important, but from technological point of view, wastewater treatment plant is the most convenient. And also, in my opinion, we should never consider water treatment plant as the place where the pharmaceuticals should be removed, because their concentration in water treatment plant is too low, whereas at the wastewater treatment plant is relatively high, so easy to remove. What's your opinion about it?
So I presented you some tools that should be used before the use of end-of-pipe solution. End-of-pipe solutions should ever be the last resort solution. So if we have means to control at source micropollutants on just to use and try to change the impact of micropollutants on the environment, we should do it. Yes, if we cannot do anything else, end-of-pipe solution should be applied. But we have to keep in mind that it will generate additional costs. It will consume more energy, as I showed you. So there are some costs, and all these costs will be covered by consumers in tariffs.
As usual.
And very often consumers are not guilty for the pollution, for new micropollutants in wastewater. So it is still just to consider to provide a good cost-benefit analysis before make decision what to do with this micropollutants. Yes, and that's why I also think that extended producer responsibility and involving producers into all this life chain is also a tool that could be very useful.
Okay, thank you very much.
Thank you.
Thank you.
If we have another short question or If not, I don't see any raised hand. We can move on to next presentation. It will be presentation of first work package of the project, which is a review of state of the art. And this review is focused on handling, monitoring, and treatment of PPCPs in water resources management. And the review includes different views and approaches from political, legislative, scientific, analytical, and engineering perspective. And presentation about work package 1 will be given to us by our colleague Mihael Brencic from University in Ljubljana.
Dear partners, dear guests, good morning in the name of Project Partner 6, University of Ljubljana, who was responsible for the working group of the thematic section 1, which was entitled Discovering Emerging Contaminants in the Water Environment, State of the Art. I would like to acknowledge also my co-authors, coming also from the same institution, Anja Torkar, Ines Vidmar, and Mateja Julevčan, who worked on the problem, collect data, and finally elaborate. So, what was our goal? What was our scope? We were intended to review state of the art regarding emerging contaminants, how to handle, how to monitor, how to treat, not only personal and pharmaceutical care products, but also emerging contaminants as a whole, in water resources management, as well as in drinking water treatment. You can find in literature and in the practical different views and approaches according to the emerging contaminants, of course, first of all from scientific point of view, but also from political legislation point of view, monitoring, and nevertheless also engineering. Our working group was divided into several subtopics represented with different outputs related to socio-political issues as well as technical and natural science questions. So how our deliverables were prepared? They were prepared based on the questionnaire, which was sent to all the partners, and partners later on sent also to the stakeholders of their country. This questionnaire follows somehow from the project proposal, but not only based on the project proposal, but it was based also on the analysis of possible interactions between water cycle and emerging contaminants as a whole. And in these questionnaires, we tried to understand various implications of emerging contaminants, not only scientific and technical, but also social economic implications, legislation, policy, management, governance. And I have to say that all the results which were obtained in the working group or working package were collective efforts and results of all project partners. So how we collect information of the state of the art of the emerging contaminants? We try to conceptualize this process on the different, let's say, compartments. So first of all, we focused on the definition of emerging contaminants, but emerging contaminants are very wide field and they are understood very differently. So first of all, we have to identify problems. Based on the identification of problems, we review monitoring strategies, but monitoring strategies are not enough. There should be also some type of analytical techniques. And we find out, of course, that there are many, not only one or two. When we have results of the monitoring and all the analysis, we have to have an idea what to do with this analysis. And so we also focused on the problem, what are the strategies to dealing with, and not only general strategies, but if there are or there is information about how to attenuate these concentrations which are found in the water environment. So as I said before, this preparation was based on the project proposal, because in this project proposal was already some definitions and some guidelines how to prepare it. And of course, we work on additional procedures of collecting available data and information. It was for us and also for the project partners and stakeholders somehow step-by-step learning process. And the procedures we have applied in our state-of-the-art can be seen also as a learning tool for those who are working in similar projects or who are interested in the topics of emerging contaminants. So we try to embed it in our reports, also our experiences on collecting data. Let's start with the results. What are our results in the frame of state-of-the-art? There are some graphs we have produced, and you can find them also in the reports. What are the most frequent words regarding emerging contaminants in our analysis? And it is interesting that it is somehow focused with the problems of European community and legislation about water. It is also interesting that there is no common definition of emerging contaminants. Even in the scientific literature does not exist, and even in national, how to say, approaches are not the same among different countries. And here you can see a graph that there is a different perception what is emerging contaminant. And for me as a hydrogeologist, it was also surprised that somehow even microorganisms are understood as emerging contaminants. Of course, there are several characteristics of emerging contaminants, and here we try to illustrate how they are related, what are characteristics of them. So, after collecting all information, we try to come to the final definition. This is definition we adopted in the project about what are and what is emerging contaminant. And we decided to define emerging contaminants represented a group of potential pollutants that are either newly created, newly identified, newly detected, or newly researched. So, what about further? What about additional information about emerging contaminants? There are some guidelines in European legislation, but according to the national legislators of all partners, there are considerable differences in research and monitoring strategies of each individual countries. And so consequently, there are also different classifications of emerging contaminants. And we try to understand what type of emerging contaminants are. So we find out that there are classifications according to the application of emerging contaminants. This is the main, let's say, but there are also many other classifications. So what are classifications? We find out, first of all, this is classification according to application. They are classified into industrial chemicals, pharmaceuticals, personal care products, biocides, and artificial sweeteners. These are classification which was found inside our group. But of course, there are in literature many others. So it is, how to say, somehow open classification about emerging contaminant application. What about different other classifications? These classifications are based on the sources of emerging contaminants from the chemical point of view. Then we have classifications related to effects of emerging contaminants. Another type of classification or types of classification are related to quantity and size. And there are also, let's say, open classifications, which are related to detection, quantification, identification, and of course, as it is always the case in the science, you have also classifications which reflects combinations of all these classifications. So what are the sources of emerging contaminants according to our review? Of course, there are anthropogenic sources, which can be infrastructure, industry, agriculture, urban life. And in some reports, the emerging contaminants are also defined as substances appearing in nature. Of course, these emerging contaminants can, let's say, travel among different compartments, among different parts of water cycle. And here on the left-hand side, we have illustrated these relations between drinking water, groundwater, surface water, then wastewater and wastewater treatment plants. And of course, this is somehow everything related to human. There are many different practices in sampling and in monitoring and also in sampling procedures. There are many different experiences among the partners and among the states from where partners are coming. There are also different practices where they are monitoring these emerging contaminants. They are monitoring groundwater, in standing water, in flowing water, in springs, and different types of accumulations, which are artificial, of course. What about the policy? What about the legislation? Who are the factors who proposing the legislation and so on? Are there any voluntary guidelines and so on? So more or less, we can find out that emerging contaminants are still under some, how to say, guidelines and not so strictly defined under legislation. So if we compare this to the guidelines on the voluntary base, we can see here the diagram of the pie diagram, where we see that some countries, they have these guidelines and some not. Some are based only on legislation, but some of them are additionally built requirements and practices. We can find out also that legislation is defined for different types of water or water compartments. And also inside of this legislation, we find also different groups of emerging contaminants, which should be monitored and considered. Let's go to the conclusion briefly. In order to investigate possible long-term changes in concentration of different substances or changes in pollution in the future, it is recommended to continue collecting data on emerging contaminants in the aquatic environment. There is common understanding that emerging contaminants occur in the environment, but that they newly developed analytical techniques need to be used for this purpose. The analytical techniques always develop and changing, and we have to implement this into our procedure. There is a lot of open questions how to communicate, how to transfer this information to water policy, water management, and governance. And based on all this analysis and interpretation of collected data, the following recommendations can be made. Existing monitoring of aquatic environment must be upgraded with new emerging contaminants. So it means that we have to include in our monitoring procedures also additional substances. In relation to emerging contaminants, all aquatic compartments must be monitored. We find out that some of them are more frequently monitored, some of them less. And especially, more data are needed for wetlands and standing water bodies. And new up-to-date analytical techniques must be included into regular monitoring. So it is also needed better understanding of emerging contaminant ecotoxicology and impact on aquatic environment. A European and national legislation related to emerging contaminants must be updated based on the existing experiences. There is a gap in transfer of scientific and professional knowledge to legislation. And finally, understanding of socio-economic implications of emerging contaminants must be improved, especially how results of monitoring are transferred to common and wider understanding. Thank you very much.
Thank you, Mihael, for your presentation. Do we have some questions concerning first work package and state-of-the-art review? I don't see any raised hands. Maybe we can also discuss topics concerning this presentation during the discussion session at the end. Actually, I would like to invite you also to MOT ProCon webinar, which will be held right after this conference. You can still register to the webinar. You can do that through a link which will be sent to the chat session. And after registering, our colleague will send you a link to the event on your email. Now I think that we can afford a couple of minutes of coffee break, and then we will proceed with the second session of the Today conference. So we are back in 5 minutes. Thank you. So I think that we all refreshed, and we can proceed with a presentation of activities and results of boDEREC-CE project. And the basic condition for the elimination of any kind of pollution is perfect knowledge of their occurrence, origin, and behavior in natural environment, and also during a technological process. And the only way to get answer to these questions is a long-term monitoring of pilot sites. And monitoring of pilot sites for our project will be presented by myself. And since I haven't introduced myself yet, my name is David Rozman, and I represent Czech University of Life Science. So we can start with the presentation. The objective of monitoring was to verify occurrence of emerging contaminants in Central European water resources and to obtain results which enable us to compare the efficiency of PPCP removal using different drinking water production technologies. The results were also further processed by modeling tools. And I see there is a problem with the full screen. So I will try to do this again. Yes, okay. We can go on like this. So for our project, we had 8 pilot sites, which were situated across the project partners' countries. There's actually one pilot site in every country, and actually 2 pilot sites in Germany, one in Bavaria and another in Dresden, in Saxony. From geological point of view, those pilot sites are situated generally in fluvial sediments, but we also have 2 pilot sites which are characterized or which are situated in karstic areas. In terms of water resources, we have representatives of intergranular aquifer pilot sites. Those are pilot sites in Bavaria, Neufahrn, and in Slovenia, Ljubljana Basin. We have representatives of already mentioned karstic aquifers. Those are pilot sites in Croatia, Jadro, Žrnovnica, and in Poland. In Austria, Weithofen and the Alps. And then we have representatives of surface water pilot sites. Those are the Polish site, Kozlova Gora, and Italian site, Po River Basin. We also have 2 pilot sites where artificial recharge and bank filtration are applied. Those are pilot site in Saxony, in Germany, Dresden-Hostowitz, and in Czech Republic, Kárany. In terms of PPCP sources, we can specify these sources as settlements, leaking sewer, wastewater treatment plant effluents, and agriculture. Because our goal was to obtain comparable results from all pilot sites, the analyses were conducted in the same laboratory. It was a laboratory of Powody Vltavy in Plzeň in Czech Republic. And the analyses were carried out according to valid procedures based on liquid chromatography and mass spectroscopy. The basic set of analyses on all pilot sites includes 109 different PPCPs, and some additional sets also include hormones and antibiotics. Limit of quantification for most of the substances is 10 nanograms per liter, and but for some substances it's also higher, hundreds or tens of nanograms per liter. PPC monitoring of water resource should include sampling of the raw water, treated water, and if available, also sampling of water at characteristic stages in the environment or in the waterworks. Now, when we are talking about nanograms per liter, I think that we are all aware that it's a very low concentration, but sometimes it's still hard to imagine what does it really mean. So I made some very simple calculations just for illustration. And we can say that 1 liter of water is 10 to the power of 12 nanograms. And if, according to internet, 1 rice grain weighs 25 milligrams, and in this case, 10 to the power of 12 rice grains weighed 25 million kilograms. So in a simplified way, quantification of 10 nanograms of a particular PPCP in 1 liter of water can be compared to finding 10 grains of, for example, wheat in 25,000 tons of rice. I don't know how to imagine such amount of rice, but I think that it could fill some very long cargo train. This is, of course, not some scientific data, but just some calculations for illustration. All monitoring operators of the project used also a common sampling procedure. according to the project sampling guide. We can move on to overview of project results. Here on the first slide, we see some results from Klara pilot site in Czech Republic. As I have already mentioned, Waterworks here use artificial recharge and bank filtration, and the primary source of water is Jizera River, where monitoring detected 35 PPCP substances. And artificial recharged proved to be very efficient in removing these substances. So only 6 substances appeared systematically after artificial recharge of water from the river. Those are carbamazepine, sulfometaxazole, acesulfam, lamotrigine, primidone, and oxypurinol. And in fact, the second technology which is applied in the Waterworks, bank filtration, appeared to be even more efficient. So none of the substances appeared systematically in samples from bank filtration. Another pilot site, which is very similar to Czech pilot site, is Dresden-Hosterwitz, which is situated by Elbe River. And here the primary water resource is Elbe River, of course, where monitoring detected 49 substances. And after artificial recharge and bank filtration, we detected, or we confirmed, a significant reduce of PPCP occurrence in water. So here carbamazepine, oxypurinol, lamotrigine, 1,H-benzotriazole, sulfometoxazole, and telmisartan still remained in the water on a regular basis, but those substances are efficiently removed from the water by subsequent granular activated carbon filtration. Now we are moving to groundwater resources pilot sites. First one I would like to mention is Bavarian site, Neufahrn by Freising. Here, shallow aquifer is used as a surface water resource, and deep aquifer is used as a drinking water resource. The monitoring revealed only some low concentrations of PPCPs in shallow aquifer. For example, oxypurinol, DEET, and diatriazate were detected. Deep aquifer was practically free of any analyzed PPCPs, with exception of DEET. Apart from groundwater, also surface water was monitored. In this case, Isar River, which the monitoring in this case confirmed quite significant impact of wastewater treatment plant effluent, according to expectations actually. But apparently, river water does not affect groundwater quality significantly. The second groundwater resource pilot site is Ljubljana Basin in Slovenia. Here, sampling of Sava and Ljubljanica rivers detected 32 PPCPs, and monitoring documented different PPCP load from different parts of the basin. And according to expectations, urban impact of Ljubljana capital was confirmed and is shown by higher concentrations and a wider range of PPCPs in the samples located under the city, or sampled, taken under the city. Here we have a first example of surface water resource pilot site in Italy. Here the monitoring was focused on a water treatment plant at Ponte Lago Scuro. In the primary water resource, the Po River, 22 substances were detected. And in groundwater, which is also, of course, affected by surface water through bank filtration, only 7 PPCPs were detected. And significant decrease of PPCPs was confirmed during treatment process of surface water. So only 2 PPCPs, iopamidol and metformin, were detected after treatment with ozonation and granulated activated carbon. In case of Kozlova Gora in Poland, water resource is a water reservoir which is filled by Brencic River. Here monitoring detected 33 PPCPs, and closer to the wastewater treatment effluent, of course, higher concentrations were confirmed. In groundwater in the area, only some temporary and local contamination with PPCPs was detected. And also here, a significant decrease was confirmed during treatment process. Here, 6 PPCPs were detected after ozonation and filtration. Those are acesulfam, metformin, DEET, PFOS, methylparaben, and valsartan acid. And the last but not least group of our pilot site are pilot sites from karst area. The first one is a Croatian pilot site, Jadro and Žrnovnica Springs, close to Split. Here, during entire monitoring period, only 4 PPCPs were detected in water resource Jadro and 2 in Žrnovnica Spring. And none of those PPCPs actually appeared regularly. Apart from springs, karstic springs, also surface water was monitored. In this case, Cetina River, which characterizes surface water in the pilot area. And in samples from the Cetina River, only 7 PPCPs were detected. The most abundant PPCPs in the area are DEET and benzotriazole. The second karstic pilot site is Weidhofen an der Ybbs in Austria. Here, local creeks and Kirschbaum Spring serve as actually were monitored, and this Kirschbaum Spring also serves as a water resource. The most abundant but irregularly detected PPCPs are DEET, progesterone, methylparaben, simvastatin, caffeine, testosterone, and lovastatin. The concentration and occurrence of PPCPs in springs is lower than in the creeks. And we can actually conclude that in both karstic pilot sites, PPCPs occur irregularly, which corresponds to specific karst flow with short residence times. And actually, also the concentrations are in general low due to high dilution. Here's another slide with comparison of appearance of selected PPCP substances on 7 water courses in Central Europe. And there's also in the last column, there is data from Weidhofen area. And here we can see that with red color on the top, we have DEET, which is substance which appears practically, or not practically, but actually on every pilot site of our project. And then under this, we have actually PPCPs listed according to their frequency of appearance. So we see that also metformin and caffeine appear practically in every site. And then we have, with lighter red color marked, we have substances which appear on 6 pilot sites. And then in yellow, substances which appear on 5, and with green, 4 and 3 pilot sites. I think this is an interesting table because it shows that many PPCPs are actually not site-specific, but we can say that they appear across Central Europe. And now to conclude, boDEREC-CE project conducted monitoring in 8 pilot sites across the program area. Sampling and laboratory analyses were completed at the end of year 2021. And we can say that we managed to catch up delay caused by epidemiological restrictions and to cope with other obstacles. And in total, 302 samples were taken and analyzed. And we can say that monitoring provided data for assessment of occurrence of PPCPs in Central European water resources and for further interpretation of their fate. So this is the end of my presentation. And if you have some questions, feel free to ask. The next presentation actually will continue with a presentation of interpretation of the data gained by monitoring. And I see here a question. So Mr. Filipek, you can turn on your microphone.
Yes, and I have another question. Could you please remind the levels of concentrations? Because the word "it was detected" means almost nothing. Were they in the level of nanograms, what I hope, or higher or lower? Because this is very important. I know this is not time for detailed discussion, but I think it is very, very important to all audience to know what the levels were detected. And are there any differences between level? Because detection at the level, for example, 10 nanograms is completely different from the level of, for example, 500 nanograms. Could you please explain shortly? Thanks.
Yes. Actually, it's hard to generalize. Every pilot site is, in terms of levels, is quite actually specific. So it also depends on the substances, of course. So in some cases, we had hundreds or even concentration close to 1,000 of nanograms per liter, but this is more or less extreme case. Those were concentrations detected in rivers. But on the other side, for example, in karstic aquifer, the concentrations were actually really very close to the limit of detection. So really 10, 20 nanograms per liter.
Okay, thank you very much.
Okay, if we do not have further questions, or do we? No, I think not. In this case, we can move on to next presentation. It will be a presentation about work package 3, which is dedicated to more thorough analysis of PPCP behavior in the environment by application of modeling tools. And this activity also led to development of a decision support making system tool for emerging pollutants. And the presentation of these activities will be given to us by our colleague Gabriele Chiogna from Technical University of Munich.
So we are ready to discuss what happened in the past 3 years in the work package T3, Modeling Emerging Contaminants Model Application. So modeling has become of great importance in the field of water resources investigation. What we have to keep in mind, however, is that models are simplifications of a real-world system. So all of them are wrong, but some of them can be useful. But useful for what? What are the main objectives, therefore, of a model? So hydrological and solute transport models are important to improve the understanding of the system, so to get a little bit more information about the dynamic, the fate and transport of the contaminants in our system, to predict future scenarios in order to evaluate, for example, if a contaminant is going to hit a sensitive source of water, and to improve also water management strategies, and to compare also among different water management strategies before implementing them. What are the expected outcomes of the implementation of new water management strategies for our system? Modeling emerging contaminants, and in particular pharmaceuticals and personal care products, is still challenging in comparison to modeling other contaminants of concerns like nutrients or like hydrocarbons, because a standardized approach is not well established. In fact, PPCPs, so pharmaceuticals and personal care products, are not commonly studied and monitored. As we say, they are still emerging contaminants, so they are new contaminants for which we are still trying to understand and to grasp some of their properties when they enter in the environment. The second issue is that PPCPs are usually detected at low concentrations, and therefore there is a higher uncertainty in the measured data in comparison to other compounds for which we have decades of experience in measuring them. And finally, most of the PPCPs are scarcely regulated in the Water Framework Directive. Therefore, there is not much experience because there was not a driving force that pushed, let's say, the community in modeling these contaminants, due to the fact that it is still quite unknown what is their effect on human health, and at least in most cases it is not. The activities that we plan to do in Work Package 3 are related to a review of the modeling activities in water management system in the countries involved in the boDEREC-CE project, to identify the needs, elaborate solution, and develop a capacity building strategy related to modeling of PPCP. And finally, in our study areas, we aimed at having some model applications in order to see how in different situations the problem of modeling PPCPs can be tackled. The outputs that we wanted to achieve were the development of a model-based decision-making tool for emerging contaminants, ModPROCON, and I invite you all to attend the webinar related to ModPROCON. We also developed training courses related to ModPROCON and in general to modeling pharmaceuticals and personal care products as massive open online courses that are now available, for example, on YouTube. And then finally showcasing applications in 7 countries for ModPROCON, so to see how this tool can be applied in our study areas. And we aimed at covering our 3 clusters, which means water resources deriving from karst water system, from surface water system, including riverbank filtration, and from groundwater aquifers. The results, considering the review, is that there is a general use of models in all countries, but this is quite scattered, both in terms of purposes for which models are used, as well as in terms of tools. However, there is a general recognition about the importance of modeling. Nonetheless, the fact that it is acknowledged the importance of modeling does not necessarily mean that several stakeholders and several infrastructures have capabilities and know-how to implement complex models like solute transport model related to pharmaceutical and personal care product. Therefore, our conclusion is that there will be the need of strengthen the capacity building in order to be able to apply this tool, which is modeling, to water management problems. The second outcome of our project was the development of ModProcon. ModProcon is a model-based decision-making tool for PPCP, and we related to it a massive open access course. So the idea behind ModProcon is to perform two kinds of analysis. The first analysis is more related to the chemical properties of the compounds. According to the sorbability, for example, of the compound, its capability of being volatilized, the degradation that the compound may undergo in the system, the solubility of the compound. We want to help the stakeholders to know whether or not they may expect a contaminant of concern to be present in the water resources. Therefore, we implemented the decision tree that was developed by the project partner BOCU into a graphical user interface such that it can help the stakeholders knowing if the probability to detect a pharmaceutical or personal care product in water is likely, very likely, unlikely, or very unlikely. In case it is likely or very likely, we suggest the stakeholders to develop a model. As we discussed, very often our stakeholders do not have the know-how to develop in-house a model. However, they must know, or they should know, what are the required parameters, the required data in order to be able to develop a model. And therefore, we help them through a data viability check that tells them whether the model can be built or if the model cannot be built. In case the model cannot be built, we try to provide some suggestions how to gather the data that are missing. And then the suggestion is to get in contact with an expert. It could be a university, a research institute, or also a company specialized in hydrological modeling that will support them in better understanding the possibility for the compound to enter the water resources that they are managing. In the MOOC, we try to give a brief training about the use of ModProcon through 7 tutorials and 3 explanations of the application of ModProcon. A key aspect of our work package was the hydrological model development for the pilot actions. We divided our pilot actions in different clusters. The first one is surface water, which includes also riverbank filtration. And as you can observe, the different project partners were allowed to use their typical or their expertise in modeling in order to tackle this issue. The first step was to develop flow models, so how water behaves in the system and how water flows in the system. And we can see here, for example, that in Dresden they used ModFlow WHM, while, for example, in the Po River Basin they used more HEC HMS or Topkapi, for example. The same heterogeneity in models that have been used can be found also in groundwater pilot action, where water resources are derived from porous aquifers. And we can observe also in this case the variability in the tools that are used. Finally, for the karst water pilot actions, we had also to study areas. In one case, the Lucas model was applied. In the other case, the karst model was applied. And we can see also in this case the difference in the expertise that is present in the different countries in order to tackle the problem of modeling water availability practically in our system. Even more complex is the situation for transport models. So in the first step, we try to model how much water is available in our systems and where it comes from. In the second step, we wanted also to observe what is the effect on, or what is the fate of the contaminants of PPCPs in the environment. Here we had to tackle several issues, like, for example, very low data availability in order to validate and calibrate the model. Nonetheless, we have had very nice intercomparison studies showing how different it can be the challenge of modeling PPCP in the environment. In fact, in this case, we ranged from physically based quantitative models, like the application of MT3DMS for the German pilot action of Dresden, to conceptual transport models, like our project partner in Poland, in which the model consisted more in an interpretation of the data due to the lack, for example, of enough information to develop a really physically based predictive transport model. The same situation occurred also for the other water clusters, in which we had, let's say, both situations where we had advanced numerical models, physically based models that predicted also the behavior of the contaminants in time, and models that were more focusing on the understanding of the dynamic of the system. In that system, the situation is even more complex. Indeed, in both cases, the developed models were both of conceptual nature. So, considering the data availability and considering the complexity of the system, the project partners aimed at better understanding, let's say, the concept, let's say, the conceptualization of the transport model of the transport processes present in their karst systems. So the challenges that we have identified in this project are related to modeling PPCP in situation where we have a low spatial and temporal resolution of the data available. And this is a common problem in several situations due to the fact that, as we said in the beginning, measuring PPCP is something new, is something difficult, and therefore we cannot expect to have very long time series or very spatially distributed information related to the concentration of PPCP in the environment. This leads to uncertainty in model prediction, and we have uncertainties also in the physical and chemical properties of the PPCP, in particular, for example, on the biochemical decay of PPCP in the environment, which can be very different depending on the site-specific condition of the system that we want to understand. Moreover, we have identified a general uncertainty in the contaminant source identification. Even in the case of the application of physically based model, it was not always clear where the source of the PPCP could be located. In this case, we, in the framework of the project, in some situations, we have been able to use the so-called inverse modeling. So, starting from the location where we have identified the contaminant, we tried to backtrack the source of the contamination, and this allowed us to estimate what could be the cause of the emission of PPCP in the environment. And as a general problem, we have identified a lack of expertise in modeling activities, in particular in transport modeling. Therefore, the big effort that has to be taken for the future in capacity building actions to train adequate personnel in order to get advantage of this very important and fundamental tool.
So, concluding, the transnational review of existing country-specific framework for model application gave us fundamental information for having an overview of the actors involved in modeling activities, their goals, and their know-how. ModProcon has the goal of helping water manager and stakeholder groups in approaching the modeling of PPCP, in getting a better understanding what it means modeling and the importance of having enough data to set up predictive models. The case studies collected in boDEREC are very important and interesting in order to show the challenges that can be present in the understanding of the fate and transport of PPCP in the environment. So thank you very much for your attention.
Thank you, Gabriele, for your presentation. Talking about ModProcon, I would just like to remind that registration for the webinar is still available through link in the chat session. And now, at this moment, I think we have time for questions. So please, if you have a question, raise your hand, and we will confirm you as a speaker. It seems that we have no questions at this moment. So in this case, I think we can afford another short coffee break. I think that some 5 minutes should be enough, and then we will proceed with the next session, which will be dedicated to work package, capacity building work package. So we are back in 5 minutes. So we are back broadcasting from Prague. I'm sure you noticed the short video inviting you to Prague city. Unfortunately, during this project, we had to cancel many live meetings which were supposed to be hosted by project partners. And I hope that things are getting better and that soon we will be also able to visit each other. But for now, it's unfortunately just a video, which is a replacement. It's a poor replacement for visiting Prague, but at least something. But now let's move on to next work package. As I already announced before the break, it will be the capacity building work package. This work package provides Waterworks a tool to tackle PPCP issues by capacity building activities and by demonstrating efficient and feasible solutions. The outputs help to reduce knowledge gaps concerning PPCP and support decision makers in European Union. And now I would like to ask Professor Valerie Vrček from University in Zagreb to give us a presentation with summary of these activities.
Yes, hello, everybody. David, thank you for your kind introduction. Let me share my presentation. I hope you see the presentation.
Yes, we see it.
Okay.
Can you just, yes, you use the full screen mode?
Yeah. Okay.
Perfect. Thank you.
Yeah, sorry. I do apologize for the background noise if you can hear, because we have some building reconstruction here. Sorry for that. So I hope you can hear me well.
Yes, it's okay. It's not interrupting.
Okay, thank you. So as you already introduced me, my name is Valerie Vrček. I'm professor of chemistry at the University of Zagreb, and here I'm an external associate on behalf of a split Waterworks in Croatia. So my talk is about attenuating emerging contaminants, some prospects and some new approaches. Okay, so let me remind you on something we call the watch list. Probably most of you are familiar with this watch list, which is a part of European legislation. You see on the left side, the first watch list was published as 2015, and then 3 years later, there is a second watch list. And in 2020, we got the third watch list, which is under the Water Framework Directive. I mean, it's only a reminder that this is a nice collection of emerging contaminants, but this watch list is, as the title tells you, dynamic and interactive report, which means it changes during a time. And I don't know, I'm not an expert in this, but probably this year, 2022, we will get the fourth, maybe, with some new emerging contaminants on list. So, for example, from the third watch list, I just copy a figure with some classification of pharmaceuticals which can enter the list of the watch list, or maybe which can be eliminated. It depends on the frequency of how often it is detected in a water, a river, or whatever, and also dependent on a biological issue, toxicology issue, and so on and so on. So this list is, as I told you, is interactive, and it's not a closed list, but an open list. So I mean, here you can see these guys in bold, like some antibiotics, sulfamethoxazole, trimethoprim, some antifungal agents. Probably they will enter the fourth list, the watch list, which is a sort of a new information and a new warning about these compounds. And maybe some PPCP will be out if they are not sort of an emergent case. What I want to say is that we can use this watch list as a checkpoint to compare what compounds, what pharmaceuticals we measured within the projects. So there is a list of, I don't know, but more than 100 pharmaceuticals monitored during this project, and one can compare, one can adjust this list to see if we have some nice overlap or not, or maybe we have some new data for the next watch list, or simply a comparison is of course needed. I think out of 100 PPCP in the monitoring list of the project, about 80 of them are detected and some of them never. So it's interesting case to compare the let's say the official European watch list with this list we have within the boDEREC project. So a part of this is already done. We published within this work package 4, we published a catalog, and in this sort of a review, we were sort of playing with this pharmaceuticals. In this first column, you see the most ubiquitous pharmaceuticals in waters all over the Europe, or even in United States and Canada. And then in the last column, you have a different pilot action areas covered by this project, and then you see if the similar spectrum of pharmaceuticals are detected in red color, which is surface water, in green color, which is groundwater, and what color is this? It's a purple color for the karst water. So the message is only that this sort of comparison is already performed within this project, and specifically it is published in this catalog of technical and management solution for PPCP. Yeah, we go next slide. We also published a chapter 6, as am I right, in the monograph entitled as Attenuation of Emerging Contaminants for the Water Supply Purposes. Here the message is each pharmaceutical, each compound, these are chemicals, has its own chemistry, and we should be very careful which methods to use to eliminate this. How it's expensive. Let's start with this diagram A. You see this a different set of pharmaceuticals measured within the boDEREC project, and you see the removal efficiency with one of the selected biological treatment method combined to some other process that it's not so important at the moment. But you see, these are data from the literature. So for the caffeine, this method works very well. The removal efficiency is 100%. For the carbamazepine, it doesn't work at all. And so on and so on. This is a very simple message that different chemistry should work with different technology and or simply different method, chemical method for elimination. In diagram B, you see a different set of methods, protocols for PPCP eliminations in terms of diclofenac and ibuprofen. And you see it depends, the removal efficiency, of course, depends on a different on the chosen method. In diagram C, you see something different. The energy consumption of ozonation, in this case, to remove carbamazepine or diclofenac. A simple message is how much you pay for this. It depends on the energy consumption. And finally, in diagram D, you see the removal efficiency dependent on time. I mean, on a season. You see here, like an example, on during the winter, removal efficiency of ibuprofen or sulfamethoxazole is much lower than during summer time. So this is just to describe my title, which tells you each PPCP has its own chemistry. We should be careful. And finally, we are never dealing with one specific PPCP. I think in the very first talk by I think Klara Ramm, there was a message on pharmaceutical cocktails, or in a broader context, we are talking about the toxicology and the presence of a PPCP mixtures. So no one is ever exposed to one PPCP only. So we are exposed to the mixtures, of course. And for this reason, I played with numbers in a way that I just selected some pharmaceuticals, from literature, but also from our monitoring list within the project. Let's say meprobamate, which is anxiolytics. So a common concentration in a drinking water is only 40 nanograms. Then you go to phenazone, analgetics, 400, carbamazepine, and clofebric acid, which is a lipid regulator. So this is the usual range in a nanogram per liter of drinking water, which is a very low concentration. But if you calculate this altogether, you will shift from a nanogram range to the microgram, and microgram is something. So they altogether present a mixture, a cocktail of pharmaceuticals, and the concentration. Now we change simply the range. We go from nanogram to microgram. Of course, if we do an additive operation, if we simply calculate this, so we should be careful about not discussing only one specific pharmaceutical, because in water, either drinking water or any environmental water, we never have the presence of only one PPCP, of course. The next problem is what I say, chemical fate of PPCP in water, which means that any pharmaceutical, any compound, any chemical enter the environment, or some unit for technology or a selected method for elimination, like a chlorination method. What you can expect is a transformation of pharmaceutical to some other compounds. Sometimes we don't know even the identity. I just show one paper from environmental science technology, quite old one, but quite famous one, in which the study is about a paracetamol, which is acetaminophen. If you chlorinate water with paracetamol, you will get some quinone products, which are 60 to 100 more times more toxic than the parent compound. So it's a problem. We should take this into account. We should consider this transformation, this chemical fate or environmental fate of PPC in water. There is a special term coined by this topic is pharmacology. Another case, another simple issue is about methadone. So if you chlorinate, or more correctly, if you perform chloramination, you will get a carcinogenic and nitrous compound in water. So the message is, okay, you can measure how much methadone we have in a river or in a waterworks, it doesn't matter, but you will miss probably carcinogenic nitrous compound if you perform some type of a chemical elimination of this compound, like a chloramination. So it's published in environmental science technology letters, and it's just a sign. It is a type of warning that we should care about transformation products of any pharmaceutical in water. And at the very end, I have a sort of a proposal, suggestion that we, or maybe we can expect this in the fourth watch list, and this is about new emerging contaminants related directly to pandemics. So up there you see a paper from the environmental science technology letters about disinfectants, about a quarterly ammonium compounds. During the pandemics, we observed a tenfold increase of production and consumption during these 2 years. Their presence in water, even in a drinking water, is already done. The measurement were performed. They can induce antibiotic resistance, the first item, and then they can also induce, they can be also transformed to some very harmful compounds after, let's say, chlorination of water. So this is directly connected to pandemics, and the next issue is about microplastics, which is also due to pandemics. I think it's about 8 million of tons of pandemic plastic already produced during the last year, and at least 25,000 tons are already in the water. This is published, and the special case about the microplastics is they can work as a vector transport for all of this PPCP we are discussing about. So my time is close to over, and I can finish with this message, and I can just remind you that the first article in a declaration for cooperation among board of expert members of the project is to encourage the exchange of knowledge related to emerging environmental contaminants. So I just show several of these proposals should be considered more or less. It depends on the follow-up activities of this project. Well, that's all. If any question, I will try to answer. And of course, thank you for your attention.
Thank you for your presentation. If somebody has a question, please raise your hand. Actually, we will go on with more presentations concerning or about this work package. Next presentation will be about DEMAST tool. I'm sorry, I just have to wait for a moment. So we have no questions? No. Okay, in this case, I think we can proceed with the next presentation about DEMAST tool. Yeah, I don't know, is Mr. Miron Sršen here with us? We cannot find him in the participants list, so please, if you are here, raise your hand so we can find you. If Mr. Sršen is not here, then I suggest yes. Okay, thank you, Petra, for calling him. But maybe before we manage to contact him, we can proceed with another presentation, which should be given by Toni Carevic. So, Mr. Carevic, if yes, we will turn you the microphone. Okay, we see the presentation already. But now we can't find Mr. Tsarevic, I think. So, Tony Tsarevic, could you please raise your hand? Because, again, we cannot find you. Okay, we have a message that he is here, but... Okay. I think we found you, and you can turn on your microphone now. We allowed you to turn on the microphone, but just please use the toolbar to turn microphone from your side as well. It's the button on the command toolbar of the Teams. Okay, so we have another person, which is yes. Okay, I think we see you, but we don't hear you. And from our side, the microphone is allowed.
What about now?
Okay.
Okay.
Thank you. We hear
Sorry
you.
for inconvenience. I will start immediately.
No problem.
Is it okay?
Thank you.
Is it okay? Petra, please. Yes. Okay. I'm talking about transnational strategy for reducing PPC in drinking water. My name is Tony Tsarevic. I hope you can clearly see and hear me. Next slide, please, Petra. As everybody know, there is no still EU common policy on trust PPCP. This policy has not been defined yet, so our task is to do something on that field. Activities connected with the trust so far are the result on the individual activities of individual member states, primarily Austria and Germany. Later, I will give examples about this, but sorry, I tried to. Later I will give examples, but for now it's enough to remember that Austria and Germany made the first step on this field. There is when we start to prepare this strategy, we saw that there is a strong need for one central body which will do some kind of synchronization, coordination, and developing of different action plans, and which is very important, one systematization of the knowledge gained. That is philosophy of practically all our strategy, and synthesize it and providing access to this data to all member states. This is very important point. Next slide, please. This central body I mentioned before will give us some kind of proposals on the knowledge gain basis. But these proposals will not be in a form of hard law, but in the form of recommendation and guidelines. We call it soft law, which will enable member states for better adaptation for future changes of legislation by this soft law. Main outputs of this strategy will be a watch list of PPCPs. Colleague Brencic mentioned it before. And second important output will be maximum allowed concentration of PPCPs in drinking water. We still don't have an exact proposal about maximum allowed concentrations, except Germany and Austria experience, I will mention later. About the strategy, we have two groups of measures. First group are passive or preventive measure. Due to the paragraph 11 of the Water Frame Directive preamble, where it emphasizes preventive actions. It's a very important approach, preventive action. It's a relatively also cheap method. We will come later to this point. So these preventive measures are monitoring, second, the determination of maximum allowed concentration of PPCP in drinking water, records of production or consumptions of drugs for humans and animals, organization of collection of unused drugs, and last but not least, educating physicians, veterinarians, and pharmacists about the harmfuls of the PPCP from drugs. Next slide, please. About monitoring, we have a two main group of monitoring. First, we called targeted monitoring. The point of duty of targeted monitoring is to determine the source of pollution in the basin, which means that we will not have same location of sampling will change in order to find a location of source. Second type of monitoring, we call it constant monitoring. Why constant? Because locations are constant and locations are only at the drinking water catchment sites or on entrance of the water supply system. So in this constant monitoring, we always take samples in the same spot. Next, please. What about determination of maximum allowed concentration of PPCPs in drinking water? As I mentioned before, it's a very important issue for the strategy. Maximum allowed concentration, as we know, of certain compounds of PPCPs in drinking water from the aspect of the impact on human health have not yet been precisely determined. Austria adopted guidelines describing the procedure to be followed if non-regulated contaminants are detected in drinking water. But also in Germany, the Federal Environmental Agency releases an official database enlisting water endangering compounds with threshold values for which no adverse effects on human health can be expected. As I mentioned, this is local state initiative, but remember central body I mentioned before, that would be one big task for this central body to analyze Austria and German experience, and according to their experience to make the proposal of some actions plan on that basis, and also to spread the knowledge from Austria and or in Germany to other state members or to other participants. Next slide, please. Germany, about records of production or consumption of drugs for humans and animals. It's very important because Germany established legal or obligation to report amount of used veterinary medical products. Unfortunately, not for human, but that would be next step for also for this central body I mentioned. it's also necessary to make records on production also for human medicine. Next slide, please. About organization of collections of unused drugs, we had some touch about it because everybody knows that we can officially bring our expired drugs into the pharmacy, but we found that pharmacy, at least in Croatia, I must put a disclaimer, they do not have clear information that unused medicine can be disposed of. So we generally believe that the population is not adequately educated about the need and possibilities of collecting them. Unused medicines, it should be introduced in order to have the best possible insight into the medicines actually used, for the quantities and types of PPCP consumed for the consumers, or the quantities of medicine that had not been used. It's also very connected with the previous point of recording quantity of produced drugs. So recorded quantity minus unused is actually load of this PPCP in some countries in general. Next slide, please. And last but not least, passive measure is educating physicians, veterinarians, and pharmacists about the harmfulness of PPCPs from drugs. I mentioned too green policy as an let's say kind of new approach where we or specialists try to find alternative products if some products have emerging contaminants in a way of PPCPs and so on, and to find alternative products in general. Also, they should consider optimal packaging size of the drug in order to cut the quantities for disposal, and also they need to analyze the possibility of extending drug validity. Also, that will decrease quantity of unused drugs. And also, there are several other activities, but there are most important. Next slide, please. And which we came to another group of activities, which are curative or active measures. What is common for this group of activities? There are these measures are very expensive because we need to build some sites for water treatment and so on and so on. There are certain preconditions for these activities in order to find optimal technology for drinking water purification. We must have relevant data on monitoring, and we need to have determined maximum allowed concentration. Why? Because from monitoring data, we will have, let's say, input in a future treatment, but about determination of maximum allowed concentration is defined output of these sites, of this purification treatment. What is between these two values are our technology treatment, and we needed to find optimal technology for that aspects. I mentioned the very high cost of these plants, and I would relate this cost with some topic on the first side, which has no something common with the topic, but this is water losses. Very important topic related to technology for treatment water. because if we have water losses, that will increase total price. For example, Professor Brencic in his catalog mentioned the specific cost of every technology. For example, one technology is 0.5 euro per cubic meter. But what happened if we have water losses of 50% in the water network? That means our real cost of technology of treatment is not 0.5 euro per cubic meter, but 1.0 euro for cubic meter, because we need to take double quantity on catchment if we want to deliver 1 cubic meter per final consumer. Anyway, we in a whole story about finding selection of optimal technology, we need very active participation of waterwork professionals. It's from very obvious reason, because they would be the guys who will operate this technology. And because of that, we put a self-estimation process before active participation. We mentioned it before. The self-estimation process will give us answer how much they can do alone and how much they need active help from outside consultant and so on. As we know, this is generally speaking, problem of PPCPs in drinking water is a relatively new problem, and it's obviously that we don't have a know-how about technology, experience of using technology for purification of water, for water purification. And our proposal is not to build pilot sites in situ, but to build micropilot devices in laboratories in order to decrease costs. And we found that we will be able to test it more technology in parallel, which is very important to future exchange of knowledge. It's also possible to change these micropilot devices between some states or spots which where they have a similar problem about concentration of PPCPs. So in general, our view is not to build for these phases, not to build very expensive plants on sites, so because we will replace it with micropilot devices in laboratories. Next slide, please. All before mentioned about strategy, I put in some in this schematic view, where we have a first group is 5 passive measures. As I mentioned before, monitoring determination of maximum low concentration, records on release medicines for humans and animals, collecting of unused drugs, and education physicians, veterinarians, and pharmacists. As you can see, in these 5 activities, there is no strict order which will be first. All of them practically can be parallel. And also there is some interaction between, there is certain interaction between some activities. For example, records on released medicines should be closely connected with data of collecting of unused drugs. But considering the second group of activity, which means selection of optimal technology for drinking water purification, from diagram we can see that there are 2 preconditions. We must have a relevant data on monitoring and determination of maximum low concentration. As you can see, we suggested as much as possible pilot sites or pilot devices. So in order to find the optimum technology, that would be that would be all from my side. Thank you for your attention, and if you have some question, I will try to answer.
Thank you for your presentation. So if you have questions, please raise your hand. I see Mr. Filipek has raised his hand. Okay, just a second. I'm sorry, sometimes it takes a couple of moments to process the Teams software.
I'm waiting, no problem.
Yes, now the microphone of Mr. Filipek is now ready to use.
Now, thank you very much. The two last lectures were very interesting, especially the final one. However, I have slightly different opinion to what you presented, because in my opinion, there is absolutely no need to applying any technology to treat drinking water, because the concentrations are at very low level. And in my opinion, there is a strong need to applying, or at least to considering technology to remove this PPCP, but from the wastewater, because then the concentrations are much higher. So I wish you had focused your attention on this wastewater treatment plant. I understand that it was not main idea of your project, but in my opinion, we shouldn't focus our attention on purification of drinking water, because first, we don't know actual chemistry. You mentioned that each PPCP has its own chemistry, and also it may happen that some unidentified products appear in the process of purification, and we don't know what is the relationships between any applied technology and the other components of drinking water. So it could be very dangerous, but in terms of wastewater treatment plant, it's much safer, easier, and the concentrations are much higher. What's your opinion in this?
I can agree totally with you. First, about need for treatment of drinking water. First of all, we must assume that we will face this problem. We must assume to be prepared. I hope we will not have similar problem. Because of that, I said we don't need plants, even pilot plants inside. But we will make laboratory devices which are much cheaper. First, second, as you could see, Professor Brencic made a totally catalog of drinking water technology for drinking water treatment. So it's a real assumption that we will face this problem, and that we will need purification of drinking water. About your second thesis, why we do not treat
wastewater?
We are talking about additional treatment probably in present wastewater treatment plants. Do you agree?
Of course.
You are absolutely right. Concentration are much bigger of PPCPs in wastewater treatment plants than in drinking water purification plants. But we must think on economic way, because by treating water of wastewater treatment plants, we purify wastewater which comes to environment, total environment. But here in drinking water purification plants, we treat only that amount of water which we'll need for drinking water purpose. I hope you understand.
I understand.
It would be much cheaper. We must consider also economic side, which will be very important. Second, I'm a little bit afraid because, at least in Croatia, a lot of present wastewater treatment plants are co-financed by EU funds, and they are still in their amortization period.
Mm-hmm.
They are not old; they are practically in the best years. I hope you understand.
Of course.
Question is what the EU or these funds will say. Okay, you will replace our equipment, or you will add some additional equipment, but our equipment is quite good for purpose we made it. I hope you understand. So I believe where I agree with you that preventive actions are much cheaper. I hope we will agree about it, because I mentioned also from preambula of Waterfront Directive, where they emphasize role of preventive actions, but in time of writing this Waterfront Directive, PPC problem was unknown. So, but in general, principle of Waterfront Directive are absolutely useful for us in general. So, my opinion, we must be prepared for the worst scenario, and we must have optimal technology in pocket, not inside, but in our pocket. Yes.
Thank you very much for your interesting lecture and your answer. Everything is clear. Much work in front of you.
Okay.
Good luck.
Thank you.
Okay, here I see another question which appeared in the chat session. It was sent by Mr. Yuri Trontel, and he's asking if we have any data about toxicity of metabolites which appear after ozonization.
This is not a question for me. This is a question for Professor Brencic.
Yes. And actually, I already see also his response in the chat. He's saying that, yes, there are some published data on toxic transformation products formed during ozonization. And of course, he can search for it. So I don't know if you want to discuss this topic, or
you asking me?
No. Mr. Brencic and Trontel, if they want to join, or we will leave it in the chat session for now. And I think it's another topic which can be also discussed during the discussion session later. So if we do not have further questions at this moment, we can go on with the third presentation of this session. I think that we found Mr. Miron Sarshen, that he's present now. Yes, he also raised his hand. That's perfect. So we just have to set him as a presenter.
Okay, thank you. Can you hear me?
Yes, we hear you.
Oh, okay, thank you. My name is Mihael. Thank you for welcoming here. And I'm actually a physician. Okay, you see my presentation?
No.
Oh, wait a second. Just a little bit. Okay. You see it now?
Not yet.
Not yet. Okay. Now?
Yes, we see it. Just make it full screen, please, and you can go on.
Is it okay? Okay.
We don't see it in full screen mode yet.
No? Well, I am in full screen mode. Okay, just a second.
Maybe it's again a problem with sharing. So you could, instead of sharing a window, share a whole screen.
Entire screen, okay.
It's probably a better option.
Okay. Is it better now?
Yes, yes, that's
Okay.
perfect.
Okay, cool. Well, I'm a physician and a developer. So this subject of PPCPs and contaminants in water, I was actually find very fascinating. And during my formal education and afterwards, I've never actually came to it. So this project was for me very, very interesting. Some of my clients are from pharmaceutical industries and are regulators. So I can add on to these past two presentations that practically all the data you were talking about used medicines and unused medicines, they are all available and can practically very easily be implemented. If that is a source of this contamination, that's also open question, I guess, because veterinary medicine and human medicine and who knows where this contamination could come from. But however, we now have it in our water. So what do we need to do? We need to measure it and know about it and know how to get rid of it. So we made this tool, which is decision-making support tool for Waterworks. It is intended so it can, in a simple way, at least as simple as could it be, present to the people or institutions who are entitled to take care of this problem and watch it and monitor it and take care of it entirely. So this is why we made this tool. So the task was to develop a tool to facilitate decision making, which is a complex process. Since you've seen these last two presentations, this is entirely true how complex this is, and it will get more complex, I guess, as we get deeper into it. Since no treatment is for everything, and we have to study each molecule in the PPCP list in order to know what to do with it. Therefore, in such a vast amount of data which has to be analyzed, we decided it is important and necessary to make a tool which would help to manage this problem. So this is a scheme of such a system, and the software is laid out exactly in this way. So the user can manage more water sources parallelly, and it can define the flow of each water. So you can define the entry or the source point, and you can define the Waterworks point. At least you have to have 2 points in which you have analytical measurements. So in order to track the change and to track the events, but also you can add on additional sources or additional sampling spots in which you can collect data. PPCPs are very, very vast amount of chemicals actually, and it would be very good if we could know. I hope we could develop this knowledge in the coming years on what is going on with these molecules, like the Professor Brencic said, that paracetamol, which has been treated, actually develops more dangerous molecule than the paracetamol itself. So what we measure in this tool, or data that we can collect, it's primarily the PPCPs that are found in the water, in the sample. So we collect the data, which is the concentrations, and it is entered into the system as one point, and then we have another sampling point, which is either Waterworks or is it some other source we can define in the flow. And then we can, if we have the data of what is the flow of this water source or this aquifer, then we can follow these compounds, these concentrations in the water as they proceed from one point to another point to another point to another point. So we can then see how different environmental influences influence this change of concentration, or how other contributing sources, perhaps from groundwater or some other contaminants, may enter at any point, or how different treatments that is applied can actually lower or not lower, expectedly lower, the concentrations of PPCPs. So here you can get the idea of how this system is laid out, and that's the way the application is configured. The main data that we collect is the PPCP concentration, as I already said, and dissolved organic carbon, DOC, in source water, total organic carbon, the UV, which is exposed, and the average temperature of the water, and also the travel time, the flow rate from the chosen start point to the waterworks. This last thing is very important, and it's very important data, because if we want to follow the concentration, it's not enough that we take the sample at the same moment. We have to take the sample as the flow goes. So that's the only way we can actually track what is actually going on with this concentration in the water that is actually flowing together with the water. The tool is actually designed for multiple users and for multiple roles. So we made it in a server-side architecture. So it's not, the number of users are not in any way restricted. You can access it through your browser, through a mobile phone, and it's modular in architecture. So it can be adopted later as we proceed, because the whole project is mentioned as to develop as our knowledge develops. Because at this moment, without the tool, we don't really have the right insight. Now, when we have the tool, with the right data, we could gain much more knowledge about the PPCPs. The tool is already available. You can access it through the HTTPS www.demast.nabu.work. It's secured, so if any one of you want to access it, we can organize it. It will be available for you to get the username and password and to try for yourself. Inside the software, you can track one or more water sources or one or more flows. It doesn't have to be only one in the software. So actually, we could track the whole water system in the country or in the region. It doesn't matter. Only important thing in this tool is from where we are actually getting the data and what are the points in which we are designing the flow to be monitored. The tool is designed to have separate configuration files for each source, so you can design the data specifically in a way to suit the needs for exploring the data of that water flow, of that aquifer. It has all the settings are configurable and very flexible. So the list of PPCPs that are inside, the levels that are that we currently suppose that are okay are also editable, so you can always change these values, and if needed, you can add more PPCPs to the list, or in different way influence the whole system with this entry of the settings. Data entry point is a very important thing. At the moment, data can be entered manually. So it means you can go to some location where you make a sampling, or in the lab, or you can just enter them one by one, which is not very practical. So we also implemented the import of XLSX spreadsheet. So that's most common way we got the results in this developing this application. Most of the sampling data which we received were made in such a way, so you can import it. Or there is also possibility if you have an automated system, which means some analytic device or some analytic stream which can produce data automatically, it can be imported directly in the application through the API. The application is equipped with the data comparison tools, which can comparison multiple location and time data sets, and as I said earlier. And a very important thing in this is that it can calculate removal efficiency, and also it can calculate decay constant. And these two numbers are very important in making decision about how to treat the water and what to do, and develop the further knowledge into this field. Data export option. All the results can be exported via spreadsheet. It can be exported through the API. So you can, if you have some other software or something that you want to pull the data or regularly be pushed to, it can be done. And also there are reports that you can export it from the application, or you can even get it by email in a regular manner, which actually makes sense if you have some automated entry of data. It can be connected to GIS data, so you can have a geolocation if needed, and the maps inside. That would be about this. What I want to say more is this subject is very, very developing, and I think stop hearing. Hello, can you hear me?
Yes, we hear you.
I just lost you for a second. Okay. Well, that's about the presentation about this software, the application that is up and running. And are there any questions?
So just please raise your hand as usually if you have a question for Mr. Sershen. If not, I think that we actually finished with the presentation part of the conference. And the next thing will be discussion. And we will proceed with the discussion actually after a break. We are actually right on time according to the schedule. So I suggest meeting again in half hour, 12:30. So see you in a half hour. Thank you.
z których korzystamy na co dzień. Odpowiedzią na ten problem jest projekt boDEREC-CE. boDEREC-CE to projekt międzynarodowy, który realizowany jest przez 12 partnerów zaangażowanych w zadania z zakresu gospodarki wodnej w krajach Europy Środkowej. Partnerzy ci reprezentują 7 państw środkowoeuropejskich: Polskę, Niemcy, Czechy, Austrię, Słowenię, Chorwację i Włochy. Liderem projektu jest chorwacka służba geologiczna. Projekt rozpoczął się w kwietniu 2019 roku i trwać będzie 3 lata.
The boDEREC-CE main aim is to establish an integrated management strategy for waterworks that guarantees increased quality of drinking water. This aim is being achieved by preparation of the recommendations for detailed PPC monitoring in water, which includes monitoring from potential PPCP sources via the watercourse or the aquifer to the waterworks. Establishing decision supporting tool, as well as giving recommendations for legislation changes on drinking and wastewater standards and preferential technical solutions.
Szczególną wagę przykładamy do studiów nad obecnością farmaceutyków w środowisku wodnym i na procesie uzdatniania wody, a także do rozpoznania czynników, które tę obecność warunkują. Badania prowadzimy w ramach tzw. obszarów pilotażowych, których w projekcie mamy 8 i które podzieliliśmy na 3 grupy w zależności od źródeł wody przeznaczonej do spożycia.
Grupa pierwsza to wody powierzchniowe, grupa druga wody podziemne i grupa trzecia źródła krasowe.
W ramach obszarów pilotażowych partnerzy testują metodykę prowadzenia monitoringu w obszarach zlewniowych, jak i na stacjach uzdatniania wody oraz prowadzą badania modelowe, które mają na celu określenie czynników wpływających na zmianę stężenia farmaceutyków w środowisku wodnym na drodze przepływu wody. W Polsce obszarem pilotażowym jest zlewnia zbiornika Kozła Góra oraz stacja uzdatniania wody Kozła Góra, która produkuje wodę dla mieszkańców Górnego Śląska.
Na stacji Kozłowa Góra mamy jeden z najbardziej rozbudowanych procesów technologicznych uzdatniania wody w ramach Górnośląskiego Przedsiębiorstwa Wodociągów w Katowicach. Próbki na obecność farmaceutyków pobierane są po każdym etapie uzdatniania wody. Jednym z celów jest określenie efektywności uzdatniania.
Działania realizowane w ramach projektu mają charakter pionierski w tej skali i zakresie. Partnerzy wykonują analogiczne zadania, w tym badania monitoringowe, co daje możliwość poznania stopnia zanieczyszczenia farmaceutykami na dużym obszarze oraz możliwość porównania stosownych rozwiązań. Bardzo ważnym aspektem projektu jest włączenie do dyskusji ekspertów spoza konsorcjum projektu, a także podnoszenie świadomości społecznej w zakresie obecności farmaceutyków w środowisku wodnym. Zorganizowaliśmy lub uczestniczyliśmy w blisko 50 spotkaniach, w trakcie których informowaliśmy o realizacji i wynikach naszego projektu. Rozpoznawaliśmy także zachowania ludzi względem pozbywania się przeterminowanych lub niezużytych leków. Projekt jest dedykowany firmom wodociągowym, ale najważniejsze kroki ku poprawie jakości wody przeznaczonej do spożycia możemy wykonać my sami. Pomóż nam zadbać o zasoby wodne. Pamiętaj, aby zużyte leki oddawać w wyznaczonych do tego punktach. Wyrzucanie leków do kosza lub wylewanie do ścieków może stanowić problem dla utrzymania jakości wody wykorzystywanej do spożycia przez ludzi.
So greetings from Prague. Welcome back again on our boDEREC-CE conference. We are proceeding with our afternoon program, and the first on the program will be discussion. And as I have already mentioned several times, we will start by showing your questions on Mentimeter. So could we please show Mentimeter on the screen? Thank you. I noticed here there are several questions concerning cosmetics. If our monitoring included cosmetics, I think that I can answer this by myself. Yes, we also detected several cosmetics or PPCPs which originate in cosmetics, especially different parabens. And in fact, methylparaben was one of the substances which was found in 4 of the 8 pilot sites. So we can say that it is quite abundant. And there is a second question. If we were detecting or if we were monitoring also metabolites. In this case, yes, I can answer that the range of the PPCPs we monitored also includes 5 metabolites of carbamazepine, 2 metabolites of ibuprofen, a metabolite of diclofenac, naproxen, veramipil, versantan, and so on, also some other metabolites. And most of the metabolites were actually not detected. The most abundant was metabolite of carbamazepine, which was detected especially in surface water, which was affected directly by wastewater treatment effluent. And actually, in some cases, the concentration of carbamazepine metabolite was very similar to the concentration of original substance in this case of carbamazepine. So yes, this is indeed a case that we cannot overlook, and metabolites do appear. If somebody else has some comment about these topics, you are welcome to join. Just raise your hand so we can see that you are interested in it, and you can ask some further questions concerning this or add some comment about it. Perhaps your own experience with metabolites, with occurrence of metabolites in water. So we have one response. So please, Mr. Filipe, go ahead.
Okay, now my microphone is switched on. I have a question and comment. It was mentioned that each PPCP has its own chemistry, and there are some unidentified products. So does it mean that we should focus on everyone separately, or, in my opinion, better, to the group of PPCP in terms of their treatment, purification? There are some advantages and disadvantages. On one hand, it may happen that in some cases we have individual PPCP, 1, 2, and in most cases we should have a group. So from technological point of view, what is your opinion? What our approach should be? So concentrating on the group or on the individuals in terms of treatment.
Yes, from a scientific point of view, actually, we always try to categorize substances in the several categories because it's, of course, easier to assess it in such way. But in case of pharmaceuticals or PPCP substances, I think it's quite a hard issue. It's hard to tackle this. Very often there are some examples of PPCPs which behave in a different manner than others. So it's hard to tell. I don't know if there is some organic chemist maybe would be able to answer this better.
Because sorry, I am a chemist personally, not organic chemist, but inorganic chemist, in fact. My first opinion is that we should divide the total group, 100 or something, into several chemical groups. And then we have to focus on every individual group separately. It may happen that, for example, in one case, membranes are necessary. In the second group, maybe activated carbon. In third one, maybe something else. And we shouldn't forget about the metabolites of the product, because this is also very important. So just to make a resume, there is much work to do in terms of scientific as research work. And after that, we have to consider any technological solutions, not earlier. So first, sharing or dividing this total group into several chemical groups, individual groups, in terms of their chemical properties. This
yes, I agree. I think this is a good actually starting point, a good suggestion for some further research, which should be also focused on the behavior of PPCPs in different conditions of the environment, actually.
Okay, thank you very much.
I see another raised hand by Mr. Brencic. We are working on it. Okay, so your microphone should be enabled. Hello, you can turn on your microphone. We still don't hear you, unfortunately. The microphone is inactive, according to Mr. Brencic. Can you check if... It seems that from our side, it should be enabled, it should be activated. But if you cannot turn it on, if you cannot unmute on your side, then I don't know where is the problem then. Okay, so maybe you will manage to connect with us later. You can try again later. So far, okay, we have another question, yes, by Mr. Yuri Trontel.
Okay, can you hear me?
Yes.
Okay. I would also like to agree with your comment that it is better to specialize on a certain group of chemicals, also in analytical point of view. It is easier to extract them and to study their transformations. Okay, So I think that on a European level, or even wider, we should concentrate to divide certain laboratories to specialize in each pharmaceutical group of compounds. For example, antibiotics, estrogens, bisphenols, PFAS, and so on. So I think that this is the right course of action. Not that every laboratory specializes in everything, but to be really good in one group of chemicals.
Yes, okay. It means that we cannot actually treat PPCPs as one group of substances, but it's better to specialize, yes.
Yes, indeed. Thank you.
Thank you for your comment. Now we could probably move on to another question from Mentimeter, which actually is about modeling. But before we change the topic, I see another hand here. So let's hear Laura Ducci.
Hello, everyone.
Hello.
Thank you for your answer. And you say that was analyzed mainly in parabens for cosmetic products. And my question is if you have found any other cosmetics in the environment, and was the cosmetics concentration detected in the water comparable to that of pharmaceuticals?
Comparable to other pharmaceuticals?
Yes.
Well, our range of analyses included actually only parabens, different parabens. There are, I think, 4 or 5 parabens in the list. And to be honest, I don't know the exact numbers right now. So I would really have to check for the concentrations to compare it with other pharmaceuticals. Maybe if some of the partners remember their numbers, they can report it right away. But in other case, we should look for the numbers in our results.
Okay, thank you so much.
Okay, so I suggest to proceed with the next question I already mentioned. It will be about modeling. I have a question here. Since you have applied different approaches of modeling the fate of PPCP, do you have any remarks or recommendation which one is the best? So I would like to ask colleague Gabriele Chiogna if he could reply. Thank you.
Hi. Sorry, can you hear me?
Yes, yes, we hear you good.
Okay, perfect. So thank you very much for this question, which requires quite a complex answer, let's say. From the point of view of the best model, of course, the ideal case is the case in which we can use a physically based model in which we know all the chemical properties as well of the PPCP that we want to model. We know where is the source, and then we can track the fate of the contaminant. Okay, and such models do exist. Of course, it is possible to use them, and to some extent have been used also in the framework of the boDEREC-CE project. One example is MT3DMS, for example, which is a reactive transport model, in which if you have a detailed knowledge of the groundwater flow field, you can model advective, dispersive, and reactive processes in order to estimate what is the concentration downstream from your source. The big issue is that these kind of models require a lot of parameters in order to describe all the processes that they aim at modeling, that they aim at reproducing. Therefore, you need parameters related to the groundwater flow velocity, parameters related to the dispersion processes in the aquifer, for example. You need parameters related to the sorbability of the compound, for the gradability of the compound. And very often such parameters are hardly available. Or let's say you need a major experimental effort and effort in the field in order to estimate them. From the chemical point of view, I would say that probably the most challenging parameter to estimate is the gradation coefficient that we have in the environment, since it depends on redox condition that you find in the field. It depends on the microbial communities that you may have in the field. It can depend also on the concentration of other chemicals which are present in the field that could inhibit the activity of the biomass present in the aquifer. So, considering that, therefore, this kind of ideal case is not always applicable, we have to rely on simpler models, in which we have to make some assumptions in order to still be able to predict, let's say, the fate of the contaminants in the environment. And the simplification that we can adopt can be, let's say, more or less demanding. We could move from numerical models which are spatially distributed and discretized to analytical solutions in which we make a simplification of the assumption related to our aquifer and to our system. Or we could, like in karst system, we will have the need of using conceptual models, mainly because in those systems, the numbers of unknowns, the numbers of parameters and quantities that are very difficult to be precisely described in a physically based model is so large that it gets challenging to calibrate and validate the model, which means to estimate the parameters that we have to give to the model in order to make predictions. And in order to calibrate and validate then the model, we would need a very long time series or a large input of data to train, let's say, our model, to make our model reliable. And such big data sets are very often not available, despite the big effort that we did in the framework of the boDEREC-CE project. We have a very, from the modeling point of view, we have a very limited knowledge about the dynamics of the contaminant in space and time in the system. But this is an issue that has to be tackled over a much longer time period. And in my view, a big help will arrive once there will be an established network, let's say, of monitoring points in different case studies, or when water authorities will have the, let's say, the regulation that they must monitor such compounds. In this way, we will have a much better overview about the dynamic of the concentration of the contaminants of PPCPs in the environment, as we do have, for example, for BTEX or for nitrate or for other chemicals that are currently modeled and monitored regularly in the framework of the Water Framework Directive.
Okay, yeah, thank you. So, yes, the modeling approach for sure depends a lot on natural conditions and on data availability, as we heard. And there is another question, actually, which is also related to modeling. Do you know how common is implementation of the modeling approaches in Waterworks across Central Europe?
Considering the flow, the quantification, let's say, of the amount of water available, our overview based on the case studies told us that this is quite commonly done. Maybe what is changing is, let's say, the degree of accuracy in which these kind of models are performed, the kind of assumption that have been performed, but in practically in all case studies, we have been able, or we have found already developed flow models that are able to quantify the hydrological cycles in the study areas. Considering transport, since the problem is more complex, the situation changes significantly. And before, let's say, our boDEREC activities, practically in none of the case studies, there was already an implemented transport model which was capable of describing the fate of PPCPs in particular in the system. So let's say, while for water quantity, the modeling approach is relatively well established, for water quality, we do have still the need of further developing a robust network also from the point of view of the practitioners.
Okay, thank you. We have another comment here on the Mentimeter, or a question rather, where it's written that to sell pharmaceuticals, we have to, so pharmaceuticals which are harmful, we have to do a lot of risk assessment, and the process is long. And there is a question if there are some quick alternative methods to such assessments, for example, models. I'm not sure if I got this question right, but I think that it's the question is about alternative methods to the tests which have to be done before the pharmaceuticals is approved to be on the market. And I think that in such case, tests are actually crucial because they test the behavior of the substance, and we have to know what is the behavior before we can actually model this behavior in natural environment. So if anybody has some further comments about this.
Well, just to catch up, since you used the keyword modeling, I may just add a few words. The issue, or let's say, yeah, we can call it an issue. The problem is that very often the parameters for the chemicals, for ecotoxicological analysis, and also for the characterization of the geochemical properties that they have, are performed under laboratory conditions. And they may be very different in comparison to what we encounter in the field. Again, in particular for what concern biodegradability. And on top of it, what we should also recognize, and it was a topic that was briefly mentioned also in some presentations before, is that it's not always the case, and I would say it is more the exception, the case in which we have only one PPCP that will lead to the problem for the ecosystem or for the drinking water supply. In many situations, it will be the concurrent detection of several elements that can endanger the ecosystem. And this is quite common in general for the risk assessment related to water resources. It's not that the risk is only generated by one single compound, but very often it is a mixture of environmental factors that could be related to, of course, contamination, but it could be also exacerbated by the presence of other stressors, like for surface water bodies, it could be sediment transport or water management or changes in the temperature of the surface water body, for example. And therefore, it is when we are talking about risk assessment, we should not focus only on the concentration of the single PPCP, but on this broader, let's say, problematic that can affect one target.
Yes, I totally agree with you. Do we have some further questions for the discussion session? Thank you very much, Gabriele, for your input. So far, I think we have another question from somebody from Saft. Or maybe not. We've seen a raised hand, but it disappeared then. Okay, it was just a misclick. No problem. So if there are no further questions or comments, I think we can proceed with our program. And I would like to ask Mr. Sven Simov to prepare signing ceremony of Board of Meetings experts. Board of Experts meeting. The Board of Experts was formed to critically evaluate all project results and transform it to practical and applicable guidelines for improvement of legislation concerning PPCP mitigation. So please, Mr. Simov, could you connect with us? Okay, so Petra Furcic will present it. Thank you. We see your presentation already. We don't hear you yet.
Now? Is it
yes, now we hear you.
Great, great. Okay, instead of I will make a presentation. So, okay, so my name is Petra Furcic, and I am a technical assistant to Split Water and Sewerage Company. And at this very end of a final conference, I'm glad to present you our board of experts. So within the boDEREC-CE project, the Board of Experts was established to contribute to the institutionalization of the future cooperation in scope of PPCP mitigation in Central Europe. And it is actually a non-profit association of interested experts who focus their efforts on the burning issue of emerging contaminants in water resources. Altogether, we have 17 board members from all boDEREC-CE partner countries. As you can see, we have 2 members from Austria, as well as from Croatia and Czech Republic, 3 from Poland and Slovenia, 1 from Germany, and 4 from Italy. I won't read all these names, but all of them are experts in this field, and they helped us in a project realization. The main objective of the Board of Experts is to encourage the exchange of knowledge and experience on emerging contaminants, to promote the need for monitoring emerging contaminants in the water environment, to boost the legislative enhancement related to the setting up of needed threshold values and including the emerging substances on existing watch list and priority substances list, and also to raise the awareness of relevant stakeholders and decision makers. So during this project, board held periodic meetings in order to critically review all project results, in order to update them with new findings, in order to ensure dissemination of results through communication with decision makers, key stakeholders, and expert community, and to ensure project capitalization and maintain cooperation beyond project lifetime. As I mentioned, beside this existing cooperation during the project, the members also signed the declaration for cooperation, where they state they common wish to foster cooperation in the field of emerging environmental contaminants beyond the project lifetime. And that is why this project will continue in some way, and this is why we ensure the sustainability of the project. So if you don't mind, I will read the main points of this declaration that ensures the sustainability of the project. Okay, so all of the members declare their efforts, consult and cooperate. They will to cooperate to encourage the exchange of knowledge, good practices, and experience, as as speakers already told us today. So also they will to endorse categorization and prioritization of emerging substances. They also declare they will to support the harmonization of analytical methods and monitoring tools so that the risk of emerging contaminants can be adequately addressed. And to promote the need for monitoring in the water environment, specifically water resources used for water supply. Our members are also willing to facilitate the identification and prioritization of emerging contaminants in the groundwater resources, to underpin the inclusion of emerging substances into the voluntary groundwater watch list, to pursue the strengthening of cooperation between academia, authorities, industry, and practitioners to enable timely information flow and knowledge transfer. And as I mentioned before, to raise the awareness of relevant stakeholders and decision makers. So actually, this final conference was, I mean, it was foreseen to have a signing ceremony today, so our members can sign this document in live, but actually circumstances forced us to sign it online. Okay, so that's why we already asked our members to sign it before, to send us their digital signature, and they did. So now we have our declaration, and we hope this project, I mean, the idea of this project will continue after this after the end of this project. So at the very last meeting of Board of Experts, all of them concluded that this project brought us very value data and value tools, and they expressed their will to use this data in their further professional and scientific work. Thank you very much.
Thank you for a presentation of activities of Board of Experts. It seems that our conference is approaching its end. I would like to invite Josip Terzic again to join us to officially close the conference. Okay, we are working on it. The microphone is now active.
Yes, I think I have some controls here now.
Okay, fine. Thank you.
Thank you for nice moderating of this conference. In the end, I would just like to express my happiness to have so many people today, even in this unfortunately online conference. There were, I think, more than 100 people present at some points. Such a large number of participants from project team, associated partners and stakeholders. I think the boDEREC project was or still is an interesting project with within several points of view, and could improve the EC management in Europe in the future, or give some small part of it. The implementation of the project was good, and I think I have to thank all the partners, especially work package leaders who did good job. And of course, we hope that this internet conferences will be over soon, so we will be able to meet live and have normal conferences and normal workshops, which I find crucial for the networking, which is one of the most important points of view in this kind of projects. In the end, we can say that we can hope that after the project boDEREC, the board will continue on their work. We will also have a monography available, publicly available for everyone that is interested in this research. And that's pretty much all. Thank you for the conference and for everything within the project.
Thank you as well for your words. I would like to thank all the participants, and we would be very glad to receive a feedback from you, feedback to today's conference and to the presented results of boDEREC-CE project. So please fill in the questionnaire at the link which will be provided in the chat section again. It should take just a minute to fill it in, and it will be very valuable information for us. Don't forget that we are actually continuing with webinar. You can register actually also through the link, or you could register during the day. And from my side, that's all for today. Thank you for your attendance and for your cooperation, and see you at some next opportunity. Goodbye.